Hey everyone, this is going to be a short 5-minute video on doing some metric conversion factors. So I have two problems set up here. First one is 55.5 millimeters converted to kilometers. And we're going to write down a couple of conversion factors first so that we have the information that we're using in this problem nicely organized, right? So the first one we could write down is that 1 kilometer is equal to 1,000 meters. The second conversion factor we would write down is that 1 meter is equal to 1,000 millimeters. Okay, we're going to use both of these conversion factors in doing this. So we're going to start the problem by simply saying 55.2 millimeters times and a line. We're going to take these conversion factors and put one half of the equation on top, the other half on the bottom, right? So we're going to look at the unit millimeters, and we're going to say we want millimeters to be down there. So that tells us that we're going to be using this second conversion factor in this first step. So the 1,000 millimeters is going to go down the bottom, the 1 meter is going to go up the top, and the units of millimeters are going to cancel out and go away. The second step is going to be using the top conversion factor, and again I want to look at this unit right here to tell me that meters up top should cancel with meters down the bottom, and I'm going to put 1,000 meters on the bottom, and I'm going to put 1 kilometer up top. That again gets the unit, in this case meters, to cancel, and my overall answer is going to be expressed in scientific notation because that's the best way for us to express this very small number. 5.52 times 10 to the negative fifth kilometers is my answer. All right, first problem done. Second problem, we're going to again write a conversion factor or two down here. So we're going to write down that there are 1 times 10 to the sixth micrograms in 1 gram. Now, it is obviously important to be able to do these problems to know your conversion factors. If we take a look at what the textbook supplies us, it says things like this, that a micro is 10 to the negative sixth. So the thing you have to sort of remember about this concept is that there's two ways to express the conversion factor. One way to express it is to say that that's how many grams are in 1 microgram, right? So in this case, the conversion factor would be grams and to 1 microgram, whereas what I did in my problem was I made it be how many micrograms were in a gram. So translation, there are two ways to express any given conversion factor. And when you express them in the two different ways, you'll be using a different combination of numbers. This is a positive 6 exponent right here. This is a negative 6 exponent right here. You don't have to use both of these. You only have to use one. Which one you use is going to be your choice. All right, back to the problem. Decigrams. We have to write down the fact that there are 10 decigrams in 1 gram. All right, so let's do the problem. We've got 1.47 times 10 to the third micrograms. We're going to go times in a line. We look at the micrograms, which tells us we want to put micrograms in the bottom. Which one of these are we going to use? Well, let's go ahead and use the second one, right? Which is what the book tells us from that chart. And that means that I'm going to put in the denominator the 1, and I'm going to put in the numerator 1 times 10 to the negative sixth grams. Then I'm going to multiply by again, looking at the unit grams, grams on the bottom, and decigrams up top. I'm going to multiply by this last conversion factor, which is in 1 gram there are 10 decigrams. All right, so, and when I finish multiplying all of this through, I'm going to get a certain answer, right? Okay, and our overall answer here is going to be 1.47 1.47 times 10 to the negative 2 decigrams. All right, so hope that quick solving of 2 example metric conversions helps with a little bit of the process. Remember, you can't do the process unless you know the conversion factors from the textbook. The conversion factors from the textbook that are going to be most important for us to know in chemistry are going to be the ones associated with the kilo, with the deci, centi, milli, micro conversions, right? Those are going to be the big ones for us to know. If I ask you anything about the lower ones, the nano, the pico, the femto, the atto, I'll probably give you the conversion factors. We can clear that up as we get closer to the test, but that's, for the moment, it with the video. Okay, thanks.